Okay, so after we're done with the supervised and unsupervised classification, okay, it is wise action or wise decision to examine the accuracy of the data that has been created. Okay, therefore, in remote sensing, we have what we call as a classification accuracy assessment. So what is accuracy assessment? Okay, so land use or land cover maps derived from remote sensing data are little of use if the classification accuracy is not assessed. Mean to say, it will be not useful if the data is not accurately done. So we have to identify either that data is accurate or not. And many studies try to ignore the accuracy or reports on an overall numbers, let's say 70%, which ignores the location accuracy. So accuracy assessment involves comparison between a map derived from remote sensing data and reference test information. So we have one data that we create, another one is the actual data, either through ground verification, either through the existing maps and so on. So we try to compare pixel by pixel how the data looks like. So the comparison is often made through an error matrix, and it is imperative that error matrix will be filled with unbiased information. Okay. So in this accuracy assessment, we are doing some sampling side. Okay. So it is important to gather different text pixels in sufficient numbers to assess the accuracy correctly. So what are number of rule of thumb to do the accuracy? Minimum of 50 samples for each land cover class in the error matrix. For every class cover 50 samples. Or if the study area is larger than 1 million acres or large number of classes, you might have to increase to 75 to 100 samples for each class. So if you have, let's say you have smaller area, you have about 5 classes, so 50 sample for each class times 5 is will be about 250 points, or else it will be much higher. So the goal is to balance the statistical needs to get a representative samples with the time, cost, and practical limitations which are associated with the project. And most accuracy assessment statistics assume random sampling. Okay. However, to make it more accurate, we suggest that you can do the certified random sampling. And this technique samples, okay, samples a minimum numbers of reference pixels per land cover classes. After we do the classification, the computer selects sites within each land cover class at random, and after that, getting the X and Y location generated randomly by the computer, then we do the site visit, okay, using the GPS to key in the coordinate that thing decided by the computer. You go there and then you determine, you get it. Or of course, sometimes we might have to use some other techniques such as using aerial photo. You might use some Google Maps, Google Earth, okay, because of the limitation that we have. Okay, auto Google Map might not be updated, but in certain cases, certain land use are not changed for a long time of period, so it's still valid, right? Okay, so after you get the informations, all these things, then we do the evaluation of error matrices. Once test reference data has been properly sampled, they are compared pixel by pixel to the classification map. So error map information will be evaluated using simple descriptive statistics. It's only just divide the total correct over the pixels, that's it. Very simple. Or using the multivariate analytical statistics. So there are several kinds of accuracy. The first one will be the overall accuracy, where total corrects divided by the total number of pixels in the error matrix. So what happened? This is the classes. These are the reference data compared to each other. Okay, commercial over residential, there are 5 different pixels. And after that, for overall 4 of 7, total row and total column will be determined. Okay, for this one determine, this one determine. So there are some changes. Let's say here, for overall column reference compared to the classification, there are 73 we identified. But from the classification to the reference, 88. So they are differences right here. So overall accuracy, it will be divided, and thus we come up with the percentage. So mean to say, the different changes of between one to another pixels, okay, it will, so this assessment creates a 93% of accuracy. So about less than 7% pixels are wrongly assigned. Okay, and after that, they have this producer accuracy, where total correct in a given class will be divided by total number of pixels in the class from reference data. Okay, so before we calculate the total pixel value, now we determine the total correct. So this indicates the probability of reference pixel being classified correctly, or this is called a producer error, because it tells the producer of map how a certain class can be classified here. So usually it will be producer accuracy. It shows you the detail of every classes, what are the errors. Okay, overall accuracy is overall, producer accuracy in more detail. They give you which classes might have might contribute the number of the overall accuracy. Okay, and of course there are multivariate statistics. There is a kappa. Kappa analysis is a multivariate technique for accuracy assessment, and it yields a kappa statistics. This measure agreement of all the accuracy, where, so you can see this is how the operation looks. And basically kappa, after we produce the overall accuracy and producer accuracy, then we calculate the kappa coefficient, where it will using the multivariate algorithm to calculate the whole accuracy of every pixels, every classes. Thus we can conclude that kappa will give you 92.1%. so it's slightly lower than the overall accuracy and also the producer accuracy. However, give you the idea that this is the accuracy of the data that you get through your analysis. Okay, and evaluation of error matrix. Okay, multivariate statistics. So kappa is used to determine if the result presented in error matrix are significantly better than random class assignment. It is also used to compare similar classification to determine if they are significantly different. So when we do report the accuracy, please include overall accuracy, producer report, as well as kappa as well. And thank you very much. Finish chapter 4.